Hello everyone, welcome to the session 6 of SQL. Today we will see the different types of constraints used in SQL. Okay, but before moving on to constraints, it's important to know like why do we use them or why do we need them? Okay, why do constraints are useful? Let's start with creating a table. Okay, let's create a table students. Okay, students. Then I will have here student ID. I'm creating a table today manually because it's been very long that I have been copying and pasting. So it will be another practice for you as well. Okay. Student ID int. Okay. And then I will mention here as PAN number. Okay. Let's give it as here PAN number. PAN number will be varchar. No. PAN number is fixed, right? We have 10 characters PAN number. We cannot have like 12 digit PAN number, correct? So I will give character 10. So it cannot be more than 10. Okay. Now first name. Okay. First name varchar 30 is fine. Then last name varchar 30 is fine. 30 characters is enough for first name and last name. Okay. Now age int. Okay. Then grade can be grade is like ABC, right? So it will be a one character only. So maximum one or fixed. We are giving fixed characters to it. Okay. And then this is enough, I believe. One we can give it as like after age, we can give it add as gender here. Gender will be char again, char one. Okay. I'll give comma here. Last we do not need comma. And it is always a good practice to have one column below the other. Okay. Don't write this way. This is not a good practice. Okay. So let's create a table. Let's run this query. Okay. Table student is created. Now insert values into this. Insert into students table name. Okay, table name is students, and it's always a good practice to write columns over here because this is the practice that is followed in real scenarios. Okay, whenever you work everywhere, because it is easy to read. Let me show you. If I write this way, student ID, comma, PAN number, okay, comma, first name, comma, last name, then what is next? Age, comma, gender, comma, grade, right? I didn't miss anything, right? Last name, age, gender, and grade. Okay, I have mentioned all the columns. Now I will write values here. Okay, you can enter write this way also. Like you don't need to do this also, but it's always a good practice to have column names here. Okay, and then enter the values. Student ID, let's make it as 100. Then PAN number, I will make it as comma and making capital AZRED 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 10 digits, 10 characters. Okay, alphanumeric. Then you can have first name as Michael, then last name as Clark. Okay, okay, I didn't give a single inverted comma here, no. That's why it was showing red line over there. Clark, then age, let's make it as 30. Then gender, let's make it as male. Okay. Now grade, he will be in A grade. Okay. A grade. Okay. And then I will see. I have written everything in one row, one line. This doesn't look good. Like it is very difficult to read also, right? What if happens if you write it this way? It looks good, right? See, you can have columns in one line and you can have values in one line. It is very easy to read and good to see also. It looks like professional. Okay, only beginner writes this way. When someone is beginner, he writes it this way in one line. But the one who is experienced and like, write the queries, write insert scripts, create tables, he writes it this way. If there are more number of columns, then you will write it this way. You will enter this column also, write this, and then you will have this here, like this way. See, easy to read, right? You know that these are the column names, these are the column names, and these are the values here. 1, 2, 3. So you will have like exactly the same way. This also. See, right? Values you can have here. You can shift it here. Right? So this is a good practice. It is easy to read. For student ID, you have 100. For PAN number, you have this. For first name, you have this. Okay. But here it is not necessary since our column names are less. So it is okay to write this in one row. Okay. Now we have like this. Now I will run this query. Okay. I'll run the insert. One row is inserted. Okay. Now I will copy this and I will one row is inserted. This scale. Let me copy it again. I will copy this. Okay. And I will here. Now what I will do, we already have the column names here. Now I will enter ID as 200. Then I will change the PAN number here to 45. I will make it as 50. Okay. And I will change the name and change the name here to my name. I will write Rupesh. And here I will write as Reshmukh. Okay. And then I will make it as 31. Male. And grade I will write it as here B for a change. Okay, and I will insert this record also here. Okay, now I will run a select query here. Select star from students. Okay, I will run this query. Now this is okay. This looks good. We have student ID 100, we have student ID 200, then PAN numbers are different, then first name, last name, everything is fine. Age, male, then grade A, B, everything is good. But if I run this query again, the same query again, here, one row is inserted. If I run that same query insert statement again, one row is inserted. Same for the second. If I run this query, one row is inserted. Now let's run select star from students. What happened? What happened here? Like we have three records with same student ID, with same PAN number, with same first name, like with exactly same records. Right? And we have another record with same student ID, same two records with same record. Same ID, same PAN number, same name, everything is same. So is it valid? Are these valid records? No, right? This is a wrong entry. This is a wrong entry. Only first two entries are correct, right? Only first two entries are correct. Rest are duplicates, right? So what you call this kind of table? This kind of table, whoever creates this kind of table, like he has created a very bad design. This type of tables are called bad designed tables. Okay. Of tables are called bad designed tables. Okay. Why they are badly designed? Because they do not have any restrictions or rules on them. Right? If you add some restrictions on this table that you cannot have student ID, same student ID in here. You cannot have student, if someone enters 100, you cannot have another 100 over here. You PAN numbers are unique. How can someone with different names, how can different people have same PAN numbers? Right? It will allow you to enter the same PAN number also. What it is here? 45, no? See? Okay, one row is inserted. Now tell me, how can different people, Michael and Rupesh, are having the same PAN numbers here? Also, there are a lot of student ID, 100 student ID should be different, right? They should be unique, right? So this table is called a bad design table. Okay, even if you try to enter null values, it will take null values also. I will remove this student ID from here. You know how to enter specific values into specific columns, right? So I will remove student ID and I will remove these values. So it will enter values into only these columns. See, right? One row is inserted. Now I will run this query again. See, how can a student ID be null? Even by mistake, it should not be null. That's why I'm saying that this table allows you to do anything, allows you to insert anything, allows you to do anything with PAN number, first name, student ID, which should not be the case. That's why this table is called a bad design table. So this is why constraints are useful. Okay, this is why constraints are useful. Let me tell you what constraint means. See, constraints, right? So constraints means rules or restrictions. Okay, means using SQL constraints, you can apply rules and restrictions to this table, that you cannot have null value here, or you cannot have double, like multiple student IDs, same student's ID in this column, or you cannot have same PAN number for different people, right? See, Rupesh and Michael are having same PAN number here. Means you can tell this table using constraints. You can tell this table, you can add the constraint over here, and even if someone tries to enter this by mistake also, it should throw error. See, you are violating something, means you are not following the rules. That's why it is throwing error. Okay, that's why constraints are used in SQL to put some restrictions on the table and create a good design tables. Okay, where you cannot have anything you want. Everything should be as per rules and as per the requirement. Okay, this is a bad wrong entries. These are like wrong entries. Only first two entries are correct. These are all wrong entries, right? You cannot have null here. Means someone has messed up this table, messed up with the insert script. So this can happen, right? We are humans, so we do mistakes. But by mistake also, we should not do this. That's why we have to use constraints into the table. Okay, now let's go to the constraint. Okay, because we have understood now why we are using the constraints. Okay, let me show you. Okay, see, SQL constraints. Okay, so SQL constraints are used to specify rules for the data in a table, right? Just we saw before this that it is used to apply rules for data. You cannot insert anything you want. You have to put some restrictions on it. Okay, then constraints can be specified when the table is created. So you can add constraints while creating a table or after the table is created also using alter statement. Once the table is created, using alter statement, you can add the constraints to it. Okay, now the following constraints are commonly used in SQL. See, there are not, first is not null constraint, ensures that a column cannot have a null value. We saw that we could enter the student ID as null also. So if you put that student ID not null constraint, if you add the not null constraint to that student ID, it will throw error if you try to enter null value into it, right? That is why not null is useful, not null constraint. Now unique constraint. Unique constraint is ensures that all the values in a column are different. Means you cannot have same values in that column. Whichever, if you apply unique constraint to the student ID, it will not allow you to have 200s over there. Okay, it will not allow you to have duplicate values. But unique constraint can have null values. Okay, but unique constraint can have null values. Primary key. This is the most important key, most important constraint. Okay, so this is a combination of not null and unique. Means you need to have a unique value and not null also. You cannot have null values also, and you cannot have duplicate values also for that column. Okay, foreign key. This is the complicated one. Okay, it is a field in one table that refers to the primary key of another table. See, foreign key is applied between two tables. It is used to establish a relationship between two tables. Okay, one is parent table and one is child table. If you are trying to insert something in child table, you need to have that primary key into the primary key value into the parent table. Means if a child table has an ID column and if the parent table has owner ID, then child table ID 1, 2 if it is there, or you can insert 1, 2 values only if the parent table has 1 and 2 records. Means owner ID is 1 and 2. See, the foreign key ensures that values in the referencing column of the child table must exist in the referenced column of the parent table. Must exist in the referenced column of the parent table. Right? That column should exist. This we will see in detail. When you will see an example, you will understand what this is. Okay, just an explanation won't help you to understand foreign key. Okay, we will see how foreign key is used. Okay, and why it is useful. Okay, now check constraint. Check constraint ensures that the value in a column satisfies a specific condition. Means, see, you will apply a certain condition to a column and you want that condition to be satisfied. Only if that condition is satisfied, then only it will take the value. Otherwise, it will throw error. Okay, we will say this. We will create a table and apply constraint to it, and we will see this in demo. Okay, now default constraint. See, sometimes it happens that you do not want null values over that. So you want something null. Example, salary. If someone forgets to enter salary, then we want to have at least 0 over there, right? We do not want to have null over there, because when we calculate the average of the salary or calculate the total salary in this month for different people or different employees, then it becomes difficult. If you have null in one record also, then it will throw error, right? You cannot do the summation of character and then numeric values, correct? That's why in that case we need default values. If you have 0 over that, then it will at least calculate the values or calculate the average, correct? If someone is newly added, like new employee, then he will not have salary, right? He just joined 10 days back, and then how come he will have salary deposited in his bank account, right? So in that case, you can have default 0 over there. Correct? So now let's move on to table again. Okay. Now, see, we know that this is a bad design table. Let's make it as a good design table. Okay. Let me drop this table first. Okay. Why I'm dropping this? Because we have entered like these entries already, no? That's why I'm dropping this. I will remove this now. Okay. I will drop this table first. Drop table students. Okay. And we will create the same table again, but a good design table. Okay, now what I will do is I will add a primary constraint here. I will first show you how you can add constraint while creating a table. Okay, now our table is dropped. We do not have any table, we do not have any entries. It will say that table do not exist. Table or view do not exist, means it is dropped. Okay, now let me add a primary key here. Let's see a primary key first. Okay, primary key means, okay, let me show you this. Primary key means you have applied a primary key to this column. Means you cannot have null values also, and you cannot have duplicates value here. You need to have unique values and not null values. Okay, let me write in the comment as well. You cannot have, now let me write now you cannot have null or duplicate values here, right? Now you cannot have null or duplicate values here. Let's see if this works. Let's create a table with primary key, just a primary key. Okay, we can drop it again, no problem. We have a drop statement. Okay, let's create a table again. Students created. Okay, now currently it doesn't have anything in it, correct? Now let's insert values into it. So see, now I'm inserting all the records. First record is inserted. Okay, now see, let's start from students. One record is there, no problem. Okay, it is allowing you to enter. Okay, now if I try to insert this again, what will happen? It will throw error, right? Because I am trying to enter the same value here, 100. It will allow this because other columns we have not put any restrictions over here. But for student column, we have put the restriction. We have added the constraint as primary key, means we are telling that you cannot have null values or duplicate values, but we are trying to enter duplicate value again, right? See, now what it will say, right? What it is saying, unique constraint value violated. See, unique constraint violated means you are breaking the rules. Primary key is a combination of not null and unique key, right? So that's why it is saying that unique constraint is violated. You cannot have 100 here, correct? So our table has worked. Our constraint is working now. Okay, now I will try to enter null value. See, here I don't have student ID now. I'll try to enter null value. Let's see what it says. See, I've taken only specific column. I have not taken 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Student ID I have skipped. Okay, student ID I have not taken. That's why it should take null values, right? Previously it was taking null values because it was a bad design table. Now see, if I try to enter this, what will happen? See, cannot insert null also. Cannot insert null into this. It is throwing error, right? So by mistake also, you cannot insert null over there, or by mistake also, you cannot have duplicate values here because you have now applied the restrictions to it that I need to have unique value and I need to have some value into it. Correct? Understood? This is why primary key is very important. Everywhere primary key is given as a reference because this is unique, no? And it cannot be null also. So that's why it is referenced everywhere. Okay, now, but this table will still allow you to enter this. If I enter 200 here, and I change the name, or let's keep it as 100 only. One more. Let's add here student ID. Okay, student ID. See, we know that it is not going to allow us to enter null values and duplicate values. Now let's try to enter 200 here. Okay, but I'm keeping the PAN number same. Okay, see, one row is inserted. See, now what you have done is you have applied the restriction to student ID, but you haven't applied to restriction to other columns, right? So still this is a bad table. Still, this is a bad table. Okay, because you cannot have same PAN number here, correct? So what is it? See, you can have null. Null is fine because someone can forget to enter PAN number. That is fine. Just consider that it is fine. So what you have to do is let's drop this table again and apply a constraint to second column also so that our table gets better. Okay, let's apply a unique constraint here. This is how you add constraints, okay, while creating table. Primary key. I want this column to be primary key. I want this column to be unique. Okay. Now, what we will do, we will write here as we will apply not null also. I don't want first name to be null, but last name can be null. That is fine. Last name can be null. That is fine. Okay. Now let's drop this table. Table is dropped already. Now let's create a table. Again, table is created. Now let's try to insert values this. First, I will insert a good value. Okay. One row is inserted. Now I will try to enter this value, same values, same PAN number. See what it will say. Unique constraint violated. because you are trying to insert the same PAN number for different students. And you know that student ID won't allow you to enter over here 100 because you cannot have duplicate values. Okay, so you need to have different values here and different values here also. Even by mistake, you cannot add because it will throw error. Now, if I change this to 50, now it will allow me to insert the values into it. Right, one row inserted. Now we have this. Right. Now what we have done is we have also mentioned that I don't want first name to be null. We have added the constraint not null, right? See, we have seen here not null constraint. Right, not null constraint ensures that a column cannot have null values. Let's test that also. Okay, let's test that whether it allows null values or not. Okay, now what I will do, I will remove this, but I will copy this record here. And what I will try to do, because we know that first two columns are now restricted, we cannot have same values. We will have to enter different ID also here, and we have to have different PAN number also, because it will throw error. Now, if I try to enter null value here in the first name and remove this first name from here also, okay. Now what I'm trying to do is I'm trying to have null value here, but I have entered the other column. See, cannot insert null. Means it is saying that you have put a restriction over here. First name you have entered not null and you are trying to insert null over here. Because by default, if you do not mention that column here, it will take as null. But you are saying that you cannot insert null over. So again, it is forcing you. It is again forcing you, and it is for good. It is again forcing you to have something into it, something into the first name, right? So we will have Rupesh here and then comma. Now it will allow you to enter this way. One row is inserted, right? Now let's run this select query. See, this is fine. Like some people have same names, right? But these IDs are different. Their PAN numbers are different. Age is fine. We will see this also. Age is fine. Age can also be same. No problem. Okay. Now let me drop this table again. Okay. Let's drop this table again and create this table. Okay. Create this table again. Freshly create a table. Okay, with constraints, like we have put restrictions on student ID, PAN number, first name. So we need to insert values according to this only. We have seen it already. Okay, now there is one more constraint pending, check constraint, right? This check constraint, we have seen not null, unique and primary. Now we will see check constraint and default constraint over here. Okay, now, in order to justify why check constraint is used, let me do one thing. See, now let me insert, see, currently we don't have any values because we dropped the tables, right? We can see only column names here. Now, let me put here H, and insert the value. Okay, now select star from students. What happened? Gender H. How can a gender be H here? Right? Gender can be either M, F, or T, right? Male, female, or transgender. So even if someone was trying to enter the correct value, but by mistake it happened, like he entered H. All right. So this is a wrong entry or invalid entry, right? So we need to put restrictions to the gender column as well, right? That no one should enter values other than M, F, or T. Correct. Now let me delete that record first. Let me delete that record. Delete from students where gender equal to H. Right? The gender equal to H. Right? Deleted. Okay. This is deleted. Now I will remove this. We don't require this. Okay. Now we don't have anything in the students table. Right? but we can enter wrong value here. Someone can enter wrong value. So still we have to make our table more better, right? So we can have here check constraint. Check, okay? Check that gender is equal to M, should be M, or gender should be equal to F, or gender should be equal to gender equal to T, right? We have three genders. So one of these should be there. Gender should be M, F, or T. Nothing should be other than this. Correct? So this check constraint will check whether we are entering the value one of this. We are entering one of these values. If we enter one of these values, then it will it will consider it as a valid entry. Otherwise, it will throw error. Let's see. Okay. Let me drop this table again because we cannot create it again. No, it is created already. And let me let us demo this default also. What happens if someone do not enter any grade, right? If someone do not enter any grade, then we want by default we want the grade to be C. By default we want it to be C. If someone do not enter anything over here in gender, in grade column, okay? And in here we have entered check constraint. Let's check whether it is M, F, or T. Otherwise throw error. Okay, I will drop this table again. Okay, table is dropped. Now I will create this table with more constraints. Okay, see, table is created. Okay, now let's see if it is allowing H. See, I'm trying now. Table column doesn't have anything because we dropped it. No, right? Now if I try to enter H over here, see what happens. Check constraint violated, right? Check constraint violated. Why? Because it is we are telling that column cannot be other than M, F, or T, right? So that's why we are entering H. So it will not allow you. But if you enter M here, it will take that entry. Correct? One row is inserted. Same way, see, we are given here like default as C. Means if you do not enter anything here, by default it will take C. Let me show you. See, let's take second. I will remove grade from here. Remove grade. I will remove B from here. Okay. Now we have till gender only. Second record. Gender M. Now I am not entering grade value. It should take null, right? By default. But we are saying by default take C. Now see. I will insert this records also. Record also. Second record. One row is inserted. Now I will run this select query again. See what happens. By default, it took C. This is why default constraint is used. When someone is not entering that grade or salary or anything you can take as an example, then we want some default values then you can use a default constraint over there. Okay. Or you can use default any also here, no problem. Any also by default n/a, right? But n/a will be 2 characters. You need to have here 2 then. Okay. Now we have seen this check constraint, we have seen this default constraint also, right? However, here now it is a good design table. Age is fine, like age doesn't matter much, but you can mention here that not null also. Yeah, I don't want age to be null. Okay, here also you can put this like this. Check age is greater than equal to 18. So it will not take anything less than 18. Let's drop the table again and see. Okay. See, label is dropped. I will create a table again. And what I will do, see, it will take these 2 records. Okay, because the age is greater than 30, 31, and everything is matching our constraint. Okay, everything is as per the rules. Student IDs are different, PAN card is different. This is fine. Like this is not null, right? We have entered some value here. Then this is M, this is M. And grade is not a problem because grade it will take by default C. But here, if I try to in this third record, if I try to put it here 70, we have mentioned that 8 should be greater than equal to, and we are entering check constraint. Check that age should be greater than 18, but we are entering 17 here. Now see what happens. Check constraint violated, because you are saying, see, it should satisfy the condition, but this condition is not satisfied. You are entering 17. 17 is less than 18. It is not equal to 18, but it will take 18 because you are saying that greater than or equal to 18, right? See, so this is how it is useful. See, it took that entry, right? It took that entry. See, 18 M and B, by default it took C. Understood? And one more thing I need to convey. One moment. Before that, okay, we can have the, see, it is always good to give names to the constraint. Okay, names can be also be given. In order to give the name, see, this is also a way through which you can define the constraints. Also, let me drop this table. Okay, let me take another, see, right click here and open SQL worksheet. Okay, I will drop this table first because you cannot create this table again. No, it will say that table already exists. So that's why I'm dropping it again and again. Okay, drop this table. Okay, now what I will do, I will take this create statement here, second tab, paste it here. Now see, this is primary key. I want to give the name to this. No, now you can add constraint here, constraint, and you can give the name. Name should be like that student PK, student underscore ID underscore PK. Means I am saying that constraint name is student ID primary key. PK is primary key. So you should give the names that you should be able to identify. Yes, we have given us that column name is student ID and primary key. PK means primary key. So you should give the name. You can give PK also, but how you will understand which column has PK, like primary key, right? So that's why always give like the names which everyone will understand. Then he will understand, yes, okay, this is a column name student ID to which primary key is given, correct? And again here also you can give constraint pan. You can give pan underscore uq, means he will understand, okay, pan number is given unique constraint. And here also constraint first name you can give as fn, and you can give as not null, nm, not null over here. Yes, I forgot, no, that's why this spelling is wrong entirely. Constraint, right? See, constraint first name not null. So it depends, you can give first name also, whatever it is. Okay, this is how. Here I will give name as constraint and ck. Gender I will write gender ck. Ck means check constraint. Here I will write constraint grade underscore d grade underscore d. But I think for this the syntax will be different. See, it is not taking this. No, for default constraint you don't need to give name. Okay, you don't need to give name, or else I will research and tell you if we can give the name to this default constraint. See, it is not taking here. No, one moment. Constraint df. See, it is not taking. It will throw error if you go to create table. Say remove the constraint specification from the statement, right? So let's remove this. Let me remove this. Okay. For default, it's very complex. Like it takes like different. But you understood this, right? Constraint names can also be given. See, now I will create a table. You should give constraint name. It is a good practice. Okay. If you do not give the constraint name, by default, it takes the constraint name. System gives it the constraint name. Okay, let me I don't want to, let's us not give the constraint name to this. Okay, so let's see what system gives the constraint name to this. I will show you that as well. Okay, let's create this table now. Student table is created. Now let's insert values into it. I will take these insert scripts only. Okay, I'll insert these scripts. I will run these insert scripts. Okay, one row created. Now let's run select star from this. See, we have all these three entries. Now you will say, why we have given constraint names here when we cannot see it here, right? You cannot see it here, but there is inbuilt table in Oracle database HR. In Oracle database, there is inbuilt table user underscore constraint. See, select star from user underscore constraint. This is an inbuilt table, okay? Inbuilt table constraint where table name. This is the syntax for this to find the constraint name. Our table name is student, correct? You have to write in inverted this single inverted commas. Yeah. It is table or view does not exist. It might be constraints. Okay. See now. Now it is running. See which table is this? Table name. Where is the table name? See, this is the table name student. This is our table, right? See, HR is the schema. I will explain you what is schema also. Okay. Right now you don't have to burden everything because things are getting complicated now. You have to pay attention as well. Okay. See, this is the table name students, and this is the inbuilt table in just like HR schema. HR schema is inbuilt into Oracle database, right? This is the inbuilt table where constraints are stored for all the tables. Okay. See, table name is student. See, constraint time is C. Constraint time is C means C. Then check constraint or not null constraint. Then constraint type is P. See here, primary key. Constraint type is U, unique. Right? See, this is check constraint. C. Understood? Let me, I don't want to display everything. I will display only column name do we have here? No, right? See, this is all table. No, you know that you can display particular columns also. So I will display only constraint name here. Constraint underscore name. See, this is the column name, no constraint underscore name, and I will display search condition here. This will be applicable only for check constraints. Okay. Now see. Now it has displayed only two columns, right? See, we have given F N N N to which column? First name, right? For first name. First name, see, FNNN name. So this is why this is important. So even if you see the constraint names here, see by default which constraint is given to unique PAN number or this check constraint also we didn't give name here, no? For this check constraint name, by default system gave it a name SYS C007506, right? And for this, see, you will understand which column because it we cannot display column here, right? So student underscore ID underscore PK, we will understand by name only. It is given to student ID. See, but this is we don't know which constraint is this, right? If we do not have this search condition here, let me tell you. Let me display this. You will not know, no? By saying the constraint names, who will say which constraint is this? SYS underscore C007506. We don't know because we haven't given any name to it. Even you, no one can tell what which constraint is this, but we can tell this constraint. See, for student ID, primary key is given. For gender, check constraint is given. For first name, not null is given. NN, not null is given. Right? That's why names are important. Okay, naming is very important, and proper naming convention is very important. Okay, understood? Now, I hope that you have understood these constraints. Not null, unique, primary key, check, default. These are the easiest one. However, let's look at the foreign key now because foreign key is little bit complicated. Okay. For that, I need to create two tables. Okay. See, here I have told you that foreign key is used to establish relationship between two tables. Establish a relationship between two tables. Okay, I will prove it to you now by creating two tables and establishing relationship between them. Okay, let's create another table. I will open one more worksheet. Okay, let's create table. Okay. Let's create a table authors. Create table authors. Okay. And then I'll give it as author ID, comma, I will give here it as int. Okay, I will give here it as int and author name, varchar 50. I will give it here it as 50, and then I will run this create table. Then table is created. We see in for foreign key we need to have two tables, one parent table and one child table, right? Consider this as a parent table. Okay, and consider this as a child table. Anything is fine. You can consider this as a child table also. That is not a problem. It depends on you, because you know that what is a tree and which is a branch, right? So it depends on you, like what you defined as a parent and what you defined as a child. Okay, I will write here just for your understanding. I will write here child table. Create table books. I will create a books table. Okay, and then here I will write book ID, book underscore ID int. Okay, and then I will write here it as title. Title I will write it as varchar 100. Okay, it can be big, so that's why. Okay, and then here again I will write it as author ID. Okay, author ID, because we know that, see, we are we these two has a relationship between them, so something needs to be common between them. So this author ID is common between them, right? I will show you how this is used now. Foreign key. Now what I will do, see what I'm doing, comma, foreign key. You have to, I will give it as name also. Okay, foreign key, author ID underscore fk. Okay, foreign key fk constraint, foreign key, this constraint. Okay, let me see the syntax what it is again. Okay, for foreign key column name, then references parent table. Okay, you should be able to read this. Okay, see, child table, foreign key column name, references parent table, means it will take the reference from the parent table. Okay, see, it is not possible for us to remember every syntax, right? So you can Google it, and then you can, at least you should be able to read it. If you are able to read it, and then you can practice also. But if you are not able to read the syntaxes, then it is very difficult for you to write any of the query. Okay, so foreign key, they are saying that you have to put the column name. Which column you have to give it as for name? Book ID, title, or author ID? I will give it as author ID, because I know that author ID and author ID is in the parent table also, and I want to reference it. Right? References, which table? References, authors. Authors what? Which column? Author ID. Right? Authors ID. Means books table author ID is referencing authors table author ID. Okay, books table author ID is referencing authors table author ID. So means here we are establishing a relationship between authors and books. Okay, see, consider, let me tell you one scenario, like author ID and author name, right? We have author ID and author name. Here also we have author ID, book ID, and title. So whichever author has written that book should have the same ID, and corresponding book should be by his name, right? I will show you one moment. Now this will throw error actually. See why, I will tell you why I'm intentionally doing this. Okay, sorry, here create table, no? Okay, now still it will throw error. Still it will throw error. See why. what it will, let me close this first. Still it will throw error. What it is saying, find the correct column names using all cons columns catalog view. See, a reference clause is a create alter statement. No, see it is saying error report. No matching unique or primary key for this column list. Means whenever you add foreign key constraint, it is necessary that whichever the column you reference should be a primary column, primary key. This column should be a primary key or unique key. You cannot reference normal column here or other constant column. It should be, the reference column should be either primary key or unique key. It is important. See, no matching unique or primary key here. So what I will do, I will drop this parent table again. Or let's do one thing. I wanted to show you how you can add constraint using alter statement also. No, see, let's do this. Add alter table authors. Now I will add this constraint to this table. No, because I have already created this table, but I didn't add the constraint. But after creating table also, you can add constraint after using alter statement. We have seen this here, right? Syntax for adding SQL construct after table is created, right? So what I will do, alter table authors, add constraint, and what is the syntax here? Alter table name, primary key, add primary key. See, you don't have to use this. You will use primary key, and then you will use column name. What is the column name? Author underscore ID, right? Author underscore ID. Now I will run this query. Table authors altered, right? We use the altered statement also now to add the constraint, right? I want to see if I can add this name also. Constraint PK primary. Okay, this will also work. See, you can add this also. Okay, you can add this also. Let me show you. Let me drop this table again. Drop table authors. Okay, and I will create this again without constraint. I will create this again without constraint. Okay, now what I'm doing is, previously we added only primary key, no, we didn't give it a name. So what I'm doing now is I'm trying to add name also, author underscore ID PK. So I'm giving this name to this. I'm giving name also. Okay, see, table authors order, or you cannot give name, but then you don't need to use this completely. You can write primary key directly also. But if you want to give name, you have to add this key, constraint key, and then name, and then primary key and this. Now let's see if this works, if this thing works. Because it was saying that it cannot, you are not having any primary key. No? Now see. Table is created, right? Table is created. Why? Because now we have added a primary key to author ID. Correct? Now we have added a primary key to author ID. That's why it worked. Okay. Now let's insert some values into this. Okay. Let me insert into, let's insert into first child table or author table. Let's, author is a parent table now. So we will enter values into 101, comma, author name. I will write it as Harperly. Okay. And then again, I will insert into another this authors 102, comma, I'll write it as George, George, George Orwell. Okay, I'll write this. I have to give single inverted commas to this, George Orwell. Okay, and then I will run these two insert statements at once. Okay, what happened here? One author's values. Okay, sorry, you have to give values also. No, here add values key. That's why it is doing here. Okay, I will close this so that you can understand what is happening. Okay, insert into this. See, Both rows are inserted. Now let's run select query. Select start from authors. Okay. We have two records and author ID is the primary key and this is the author name. Right. Now I will show you how what I was talking about relation between two tables. Now I will insert into books. Okay. Book ID is 1. Okay. Title is To Kill a Mockingbird. Mockingbird. To kill a mockingbird. Okay. And then I will write author ID is 101 here. Huh? Okay. And then again I didn't give values here. No? Values. Okay. Then insert into books values. Okay. And then 2 comma. I'll write here it as 1984. Okay. Comma. I'll write it as 102. Okay. I'll run both of this now. Inserted. Now I will show you what happens. Okay. Select start from books. Now see, I'm running this here. Okay. And I will run this here. Books. This is a child table, right? Now, let me tell you why the relationship is very important in this and why do we use foreign key. Now, we know that Harper Lee has written a book, To Kill a Mockingbird, correct? Means, and this George Orwell has written a book, 1984. Now you can see that author ID 101 Harper Lee corresponds to author ID 101 To Kill a Mockingbird. Means this book ID 1 or To Kill a Mockingbird book is written by whom? Harper Lee. Right? And what you will say that George Orwell, author ID 102, see, author ID 102, you do not need to have author name here. We have a separate author details over here. Right? See, who has written this 1984, how you will understand? If you see this author ID 102, oh, author ID is 102, I will go to authors table and I will see which ID is author ID 102. So it is George Orwell. Okay, George Orwell has written that book 1984. Understood, right? This is how the relationship is established using foreign key. However, let me show you one more thing here. If you try to enter something which is not there in authors table, you are trying to enter into books child table. You can enter anything in authors. In authors, you can enter 103, 104, 110, anything. But this table is referencing your parent table. That's why if there is no entry of this 103, okay, let me enter another record. Insert into books values. See, 3 comma, let me enter another thing like Pride and Prejudice. Pride and Prejudice. Okay. Prejudice. Okay. Now this comma author ID I will put as 103 books. But do we have 103 in authors table? Do we have? No. See, author ID is this 101 and 10. We have only 2 entries. So this will fail. What it is saying, integrity constraint, parent key not found. Means unless you have the entry in the parent table, that is authors table, you cannot enter anything in the books table. This is how the data integrity is mentioned. Means anyone cannot enter the book details without the author ID. Understood? This is why foreign key is important. Understood? This is why foreign key is important. See, you can take an example of this also. Like someone who can take the admission, the one who has done the registration or who has paid the registration fee can take the admission. Means you will have one registration table and you will have one admission table. Here admission table will be a child table. Right? So unless you pay the registration fee, you cannot take the admission. So once you have paid the registration fee, you will have the entry into registration table, and then you can make an entry into the admission. You can take the admission and you will have the entry into the admission table also. Correct? This is how it works. Okay. So I will request everyone to practice this. Okay. Practice this alter syntax also. These are exactly same how I added primary key over here. See, add constraint name, unique column. I will help you with one more. See, here I will add unique constraint to author name also. I will add one more. Okay. See here. Alter table authors, add constraint. Okay. I will add to author name, no? Author underscore name underscore UQ. Unique. Unique. You do not have to be add key, right? Unique. And then column name. Column name is author name. Right? Now I will run this query. See, table authors altered. So let me show you in that table also. Where did we run that? Here, no? That query. Here, see. Here I will put it as authors table instead of table. Okay. Now see constraint names. See, author ID, primary key, author name, UQ. Both constraints are got added to that table. Right? This is how you can use alter statement to add the constraint even after your table is created. Okay. So I hope that everyone has understood these constraints because these are very important to design a table. Otherwise, your table will be a bad table or a bad design table. Okay. To make it rigid or better, you need to use that constraints properly. Okay. And at the same time, I will request, like, see, I am creating a playlist SQL. I've created a SQL playlist in the YouTube channel. Okay. And in that playlist, whenever I find a time, I upload the videos. Okay. In sequence wise, I do not upload like random videos. I upload videos very sequentially. Like after this, you have to do this. After this only you can learn that. That's why I took referential constraint in the last, because it involves two tables and it is difficult to understand. But you have to practice this. Okay, this is also important constraint, reference key. It is used between two tables. So what I was saying is I have a SQL playlist in my YouTube channel in which I am uploading the videos, right? So if you do not see, I upload videos like on random day whenever I find time, mostly on weekends or after 2 days or after 3 days. So if you do not subscribe or press that bell icon, whatever it is on the YouTube channel, you will not get to know that I have uploaded a new video on that channel. Okay. So I will request everyone to subscribe and press that bell icon over there so that you will get notified whenever I upload the videos over there. Okay. Because I'm not going to stop only with SQL. After SQL, in order to be a complete package, you need to have one query language, one programming language, and one cloud technology. Then it will be a complete package. So one of these is SQL. SQL is required everywhere. Even in networking technology also it is required. Even in every task, every project, SQL is required. Okay. But at the same time with SQL, you need to have Python and cloud. One programming language you need to have knowledge of, one programming language, which is Python. We are going to take, because I will be creating a separate playlist for Python also, and one more playlist for AWS cloud also, because I don't know Azure. I have learned like AWS cloud. Okay. Once you learn all these three technologies, you will be a complete package and you can apply anywhere and you can get a good job. Okay, so this is the reason I am requesting everyone to subscribe and press that bell icon so that you will get notified whenever I upload the videos. Okay, so let's end this for today. We are done with the constraints. Okay, I request everyone to practice and subscribe my video. Okay, see you in the next session. Thank you.